In translation, so we have transcription, which again is DNA to RNA. In translation, there are some steps that you will want to be familiar with. There's initiation. This is when the ribosome will join with the messenger RNA and wrap around it. It will look for the start codon, and as soon as it reads the start codon, will have the tRNA to bring in the first amino acid. Then the next step is elongation. This is a continuation of bringing in the tRNAs with the anticodons and corresponding amino acids. And so the ribosome continues to help form this protein by creating peptide bond between the amino acids as it moves from codon to codon. And so this is a continual process until a stop codon is reached, and then we have termination, and then the ribosome will release the messenger RNA. So what happens to these proteins that are made after the ribosome? Well, they will head off to the rough ER usually, and they will either be created or turned into lysosomes if it's products or proteins that the cell itself needs, or if it's products that the cell is supposed to secrete, they will be turned into secretion vesicles. And so the ER will help modify and package somewhat and then send it off to the Golgi apparatus, which will finish packaging up the proteins into transport vesicles. And one other term you should be familiar with: when we have several ribosomes that can cluster together and translate the same mRNA, we have a polyribosome. That's what polyribosomes are. Now this means that there's great efficiency with translation when you can continually be creating polypeptides from one messenger RNA.